Now we are going to discuss what it is that will allow us to make modular components going forward. The first directive that we can use is substitutions. Now you've seen substitutions before. ESPHome sensors file has them right at the top, as you can see. And they are very useful. They like global variables. They can be used in any module we want. So we set them once and we forget it and we use it. This is the first thing that we are going to introduce in our modular system today. Now, I am going to create a file, and I'll talk about that file a little more throughout this tutorial series. In my ESPHome folder, I will go and click over here, over here, and create a new file. I am going to call this file ESPHome modular to that. Oops. That. Okay. .yaml. Okay. So this is the file that we are going to create. And just to show you, I've done it here on the web server, but I could have, and I'm going to close this. The first thing that you're going to see is that it's available now inside of the ESPHome dashboard. And that is because anything that is in the root of that folder will be available to the ESPHome dashboard. And much like you saw, I didn't put any code in it. If I open it, it is empty. Now, as I said, when we work with modular techniques, we will not open the code in here. So what I will do is go over here, close this one, and as you can see, here is a file and it is empty. I am going to close this section as well. And from here, we're going to start inserting code. And let's start with the substitutions. And I'm going to explain to you exactly what those substitutions global variables are. For a good part of this tutorial, we'll be using this. This is a ESP32C3 Mini by Expressive. And I want to thank one of my Patreons and man that you have met my live stream, Steve, who kindly donated these to me to do tutorials with. So shout out to Steve. I actually have one that is prepped for these tutorials. I didn't want to show it to you because there is stuff on it right now. And I'm going to have to strip all of that for the future tutorials. Now let's move along. And one thing that I've added to this, and I'm just going to do it now, is I've added something called region. And we will talk about region, I promise. In my case, it's Africa, Johannesburg. For you, it will be something else. I will, as I say, I will talk about region, why it exists in a later tutorial where I'll speak about about the problems that I faced modularizing, and particularly with the time component. Okay, so let's go through this. Device internal name is something that we are going to use extensively. It cannot have dashes, so it's underscores. The Wi-Fi name is dashes and not underscores, although it works with underscores as well, but it can be dicey. Then the friendly name, obviously, is the friendly name. In fact, I think that if we go over here and I get out of here and I go all the way here, why not, and come back to ESPHome. Now it hasn't updated it. Until it builds it, I think it doesn't update it, but this is the friendly name, and you'll find it on that it's auto appended to all of the names. Then I've got the IP address that I leave up there, and you'll understand why it's there. In fact, it's already there in my room sensor. It's going to be in another file, and I don't want to modify those files. Then there is the device sampling time, which is generally 30 seconds. I don't see why going any faster at least for us, why going faster would be of any use. And lastly, obviously, the region, which I've just stated. Now that I've explained all of these properties, I'm just going to make a note about the device internal name now, and I'll talk about it again later. For me, it's a grouping inside of Home Assistant. So I know that if I have a problem, I can look in the IDs. I can search in the IDs for that name, and I will find what I'm looking for. Yes, the names can get a little long, and that can cause problems at times. Try to keep your name as short as possible. In fact, you wouldn't call it ESPHome ESP32C3 Mini Expressive. You would call it ESPHome Kitchen. Maybe ESPHome Kitchen Display. But I wouldn't go any further than that. Okay, let's move on to the next section, where I will explain to you the include directive. Let me introduce to you the include directive. This is the magic behind the modular approach. It promotes reusability and scalability and works across all of our projects. With this directive, we can easily break down our devices into modules. We will be leveraging this feature in all of our upcoming series and project tutorials, starting with Advanced Room Device and the Weather Station. The basic of the include directive works by inserting text from another file into the file you call. It's important to understand that you cannot duplicate anything. So, for example, if you want to have sensor in the DHT module and sensor in the SHT40 module, you cannot do that with this specific method. Now, what does the method look like? Very simply, two chevrons followed by a colon and space, exclamation mark, include. And it's going to be the path of the file and then the file name. Score name.yaml. This is what it looks like. Nothing fancy, nothing complicated. But as I said, it does have a lot of drawbacks. It has its place, and in fact, in the advanced room sensor, we will be using this technique at least once. The real power comes in with packages. A few things I need to tell you about the package command. You'll see that packages is right here, and there it appears. That package command needs to be as close as possible to substitutions, as high up in the file that you can put it. Because basically what it's going to do is that it's going to create these little packages, and those little packages can have duplication. The sensor section being a typical example. The sensor section could have a sensor for the DHT22 or the SHT40, but also for a humidity sensor or for a GPS, for all I know. And we want to be able to put the concerns of one single sensor or one single concern into a single file, meaning that there will be duplication of certain parts of that file or certain components, coming back to sensor or binary sensor or text sensors, just to give a few. Using the previous methodology, this wouldn't be possible. But let's see how that looks. So packages, and then we would put the package name. Package name 1, and then include, that's perfectly fine, and we would say file, path, file name. dot YAML. The first part of its superpower I have just explained. It merges section by section different components from different files. And I will demonstrate that better at a later stage. Additionally, packages can take variables of its own, which is its second superpower. So we could change that code and make it look like this. Package name, include, and we will tab and say file. Oh, and this is a problem that you will face. That nResolve tag include, it expects it in the same line. I think that it's running on an older version of the ESPHome definition, and part of that is why it can't compile either. So ignore unresolved tag. What we will do though is now that we've got this part sorted, we're going to go down and it can take, much like we've got substitutions, variables. And we are going to use a variable that's going to come back for us multiple times. I2C address, which is a good variable. And I'm going to put a random address, but all of a sudden you can have this. Now I'll show you how to do all of this better in a later tutorial, but I want you to understand that we've got a lot of power. It has two superpowers. Number one, it merges the code on a line-by-line, nearly a line-by-line system. And secondly, we can even pass it information that we want it to use, meaning that we can create certain modules that we would need to change from project to project, but thanks to this, we won't have to. And then there is the last type of directive for packages. And I'm not going to dwell on this one. We will use it down the line, possibly in the weather station project or a project after that. But we can also have a remote package. So remote package. And instead of having file, we will use URL and a URL. And I'm going to take a typical URL that we would be using in a case like this, and that would be GitHub. GitHub.com and some repository of some sorts and a path. And then we would have file, and the file would obviously be the file name. File name dot, yet again, YAML. So we could have a repository. In fact, I'm going to start publishing these, and you could start referring directly to my repository, and it will compile. It is possible to do. I'm not going to use this technique in any tutorial anytime soon, except for one case, which in my opinion will come late into the weather station tutorial series. Well, I think I've covered the basics of the includes and the packages. It has more tricks, but I will explain those in later tutorials when we start having the need for it. At the end of the day, leveraging the include directive and packages feature can greatly enhance the organization and scalability of our ESPHome projects. I will leave the ESPHome reference link on my GitHub page. Link in the description. Speaking about our standards and conventions, I think it's important to have a good folder structure. The structure should be simple enough and easily understood, yet flexible enough to accommodate future needs. The structure will be located in the ESPHome folder. So this folder over here. To show it to you a little bit better, I think I should return here and open Studio Code Server here. And we are going to just close this. The ESPHome folder is under config, ESPHome, and there it is. Anything that you put into the root of that folder will be shown in the dashboard, in the ESPHome dashboard. But this is where we're going to create our folders. Things that you will find in that folder right now. You will find, if you've deleted any devices in the past, you'll find the trash. Now that is created by the dashboard itself. And that's all you'll find. File-wise, you will find the secret file and any devices that you have created. How are we going to lay this out? Now, I'm going to take the way that I do it and explain to you how I do it and why. You can do it any ways that you want, as long as it makes sense to you. And remember that something that makes sense to you today doesn't necessarily make sense to you in a year or two from now. So I'm going to stick to very basics. The first thing that I did is I created a folder called archives. And you will actually see there the device simulator that we built in room sensor tutorial. And the prototype is one that I use to prototype things. The next one, and since this is going to be a folder, we're going to right click and we are going to say new folder, is going to be the board folder. And this is where we are going to put the definitions of our boards. However, I go one step further with this and I create an ESP, and not in capitals, ESP32, and they're all in small letters. So if I create an ESP32, it comes to sense that there will be an ESP8266. And just because I've got a few lying around and I do use them, and in fact, they're going to come up in this series. Another one is the RP2040, which you may know as the Raspberry Pi Pico. Okay, so we've got our boards sorted. And later down the line, you might want to put more boards. I don't know. The next that I recommend is a Commons folder. Now, the Commons folder is the folder where we'll put things that are valid across any boards. So things like Wi-Fi, Bluetooth, there'll be a settings file, which contains a lot of information in it that we keep on copy, paste. We won't have to do that anymore. One more is the includes folder. And the includes folder has nothing to do with our components. The includes folder is there for any C++ files that we include. And it does happen from time to time where we have to. And again, I think that it is in, or it will be in our weather station that will need to include some C++ files. And in a later, much later tutorial, when I go into the very advanced functions of ESPHome, I may actually even show you how to create some of those files. The next one, and actually it's not the next one, it's the next two, are pretty much linked together. One is called peripherals. Peripherals. And the peripherals one is anything that, like a screen, is a peripheral. It's not a sensor. It's more, peripherals are more for output and much less for input, although they can be input as well. So a keyboard or a mouse would be a peripheral. And in there, I would have a folder called, and I think a good one that a good one to have is the SPI, because we have SPI devices that are going to be run through peripherals, particularly screens. I mean, here is a screen. Here is a screen. It's a SPI screen. It's got touch sensor, who are also, as far as I remember, SPI driven. And it's got a little core module here as well. And we will approach that very soon in our room sensor tutorials. So the next folder is our sensors folder. And our sensors folder, again, will be divided. And it's mostly for me to be able to find things. So the sensors folder is divided into analog. I'll leave you two guesses as what goes in there. And we're going to do another new folder. And the next folder is going to be binary. And another folder. And that's going to be core. Sorry. And that's going to be Bluetooth. Bluetooth. And yes, we do get Bluetooth sensors embedded into ESPHome. I've actually got one specific one that keeps eye on my gas levels. And then we're going to add, after that, the core. I'll explain to you why this is necessary in a future tutorial. And I'm going to create another one called one wire. And the few last ones are I2C, then SPI, and lastly UART. Okay, I'm going to collapse that. In the next tutorial, you will have all of those folders on my GitHub page. Not in this one because they're pretty much empty and it's an empty shell. And I don't know how GitHub would handle that. So after that, I have a folder in the root of your ESPHome that is called templates. Templates will hold the templates for specific boards that we can then modify at our will. And that will be all. So this is what it looks like. So I'm just going to scroll up a little bit. I'm going to open up the boards. Peripheral has only got SPI, and the sensors, and rename templates to templates. There we are. So this is what my folder structure looks like. If you want to use something different, you're more than welcome to do so. Basically, this folder structure will hold the repository for all of our components. And within boards, for example, we will have ESP32s, and under ESP32, we would have a C3 mini. And I'm not going to do it now because I do go deeper into these in future tutorials. As a matter of interest, I've written all of these tutorials whilst my voice was gone, so I know what's coming in details. Look, as I say, this is my way of doing it. Again, it's a framework. And as all framework, you can adapt it to you. At a point, it senses 3 deep. And I went, no, this is too deep. Bring it back. It's not going to be useful. So we'll possibly expand this folder structure in the future, but we need to stay well organized. I think we've covered this piece rather well, and let me see you in the next part. The system is not flawless. There are a few catches and trade-offs to consider. One notable issue is the dreaded secrets YAML file. And if I open, obviously if I open this file, you will not have that problem. But in later tutorials, what will happen is that we have, for example, in ESP32, let's create a new file, and we're going to create a file called c3miniexpressive.yaml. I'll explain to you why that naming convention is used, but the first thing that it's going to tell you is that we do not have the ESPHome peg anywhere. And that's correct, we do not. So what we're going to do here is just copy this, the ESP32 section, and this is what it's going to look like. And just for it to give us a break on the ESPHome, we're just going to put ESPHome here, just like that. And I don't know what that error is, because I do not have it on the other side. Okay, doesn't matter. The point that I'm trying to make is that we are going to end up with some issues. And the way to solve those issues with the secret.yaml file that is missing here and there is to, in our folders, create a new file called secrets.yaml in those folders, and you'll see them littered right through all of the folders. And all it has, I am going 1, 2 up, so 1 folder, 2 folder, and I'm just going to say secrets.yaml. And that's all you need. And as I say, it's 1 folder, which is the ESP32, 2 folder, which is board, and there is a 3rd folder, and it sits right here, secrets.yaml. And that's a problem that you will have quite regularly. There is another issue that regarding the Wi-Fi name. I will deal with that at the relevant time. The second part of the issues and the drawbacks that you may have with this is, once you've done your file, and as you use it more and more, it's going to get more and more difficult to change it. In fact, from the word go, you should have in mind, I'm not going to change that file again. Because if I change that file again and 10 devices using it, I'm going to have to do changes to 10 devices. So think that way. Also, it's important to note that if the device code breaks, the device doesn't break because it won't upload it to the device. So you shouldn't worry about flashing a bad version of the firmware. It won't happen. I'm not telling you that you can't edit these files. And in fact, in future tutorials, we're going to come back and edit these files quite often because we're going to build our knowledge slowly, much like the old African adage that says, how do you eat an elephant? 1 bite at a time. And this is the approach I'm taking with this. Honestly, you can go and edit these files for sure. And I will show you how to do so responsibly and step by step. and why we would want to and why we wouldn't want to. So be patient. I promise you, by the end, I think I have 6 tutorials on this. You will have a firm grasp of what I'm talking about today. I think it's time we wrap off. I don't know how long this tutorial has been, but I know it would have been quite a lengthy one. In the next tutorial, we're going to really start writing code. Not yet bringing it up to the device. I don't think. I think it's only in the 3rd one that we do. But in the end, you will have such a grasp of the modularization system that it should come naturally to you. I want to thank my Patreons, both Miguel Avello and Stephen Brouillard, for their generosity. And again, as I say, thank you, Stephen, for the boards. I'm going to use them for this tutorial, and I'm sure I'm going to find good use for them in the future in other tutorials and other functions here. To you, my audience, I want to express my heartfelt appreciation for your dedication and time spent learning something new and picking my channel to do so. Your support and encouragement does not go unnoticed. And honestly, I had hoped to bring this specific tutorial out much earlier. I wasn't. I suppose nature was against me at the time. I'd like to ask you to remember to participate in the polls that I regularly post in the community section of the channel. Your feedback and opinions are crucial in guiding the growth and direction of the channel. In fact, I put up a poll: should I create this and should I start with this before I start with the weather station? And yeah, you wanted this first because the weather station is going to be done modularly. I want to bring you something that simplifies your life, not only this monolith of a file that gets very, very confusing. And I know it gets confusing because I get confused. I also want to emphasize that you are the backbone of this channel. Without your support, this channel wouldn't exist. And thank you for being part of this community and helping it to thrive. We've reached 1,000 subscribers a while back now, and I didn't expect getting there so quickly. So thank you very much. So to wrap up, today we've covered a lot of things, and from substitutions to packages to what a module is to a whole lot of coding standards, creating the folders, and why we're doing it that way. And I will be going deeper into all of these in future tutorials. But I hope that you found this tutorial helpful and enjoyable. If you did, consider liking, subscribing, hitting the notification bell. So yeah, I want to thank you. And this is Pascal signing off, and see you in the next tutorial.